Hey, how's everyone doing? Getting started here. Just finished my lunch. Yay! Quick lunch right there. Making sure. Yep. Okay, let's get started right here. First question, Mohammed is asking, can we go over question 3 for 474? Let's go take a look. You're welcome, Jack. Good to see you here. Good to see you, Mohammed. Caroline. I think we had one more. Sorry, I just went away from the chat for half a second. Also, Kylie, good to see you here. Let's give out some points. Mewbot needs to re-wake up. Let's re-wake up Mewbot. I should start like a macro. I should write a macro that every time I start the stream, it does this. Kayla asks, watch under in Canvas. Today's, yep. Awesome. Yep, Kayla, you're totally right. No, exactly. No, that's exactly it. I was like, well, we'll do it. Because no, we'll do it. Ray Lauren HGT says, Kayla, thank you so much. We're throwing out 100 points. Kayla is totally right. Lots of practice today. Mewbot, you awake? Oh, Mewbot, say hi. Mewbot's awake. Mewbot, give out points. What's going on? What is going on with my things? Let me try this again. There we go. Okay. Working. Let's get the 474 going. The 474 assignment. Question 3. Gonna give some hints, but not do the full problem. 474. Assignment 3. Okay. I'm going to arrange my screen. Make it big enough so people can see. Good. Okay, let's do 474. Question number 3. Thank you so much for everyone for all this positivity. Another 50 points out there. Here we go. 474, question 3, homework 3. Okay, we're going to go here and search through the document. Go down here to, is this question 3? That is question 3. Okay. Consider the following algorithmic trading strategy. Wait until a stock has closed lower 3 days in a row. So what we want to look at right here is some stock prices where you could watch Pepsi and it could be like going down from like 120 a share to 118 a share to 115 a share. And then after it goes down 3 days in a row, you're going to what? So after the stock goes down 3 days in a row, like it was at 120, then it goes to 118, then it goes to 116, and then it goes to 114. So we need 3 days in a row of going down. You're going to do what? So when the stock goes down 3 days in a row, you're going to decide, that's my moment to do what? What are you going to decide to do? So the stock's going to go from like 120 to 118 to 116 to 114. So look, yeah, you're going to buy them. Great job, HDT and Muhammad right there. You're going to buy them because first time it goes down from 120 to 118, it's one time down, 118 to 116, and then 116 to 115. It's going down, down, down. You're like, it must go up. It's bound to go up eventually, right? So we're going to buy it. So when we do this right here, we're going to read in the Apple stocks right here. We're going to save it to the object APPL, and it's got the 2010 rows in it right there. So here's our stock. Let's take a look, and there we go right here. A lot of info in this. A lot of info. We're not looking at all this information. I think we're just taking the close right here, right? So we can take a look at this, and we can see what was happening right here. Ooh, what's it mad about? Might need to reset my R. It's mad. I think I've got packages conflicting. So we're going to reset the R as we always do. Don't save. Resetting the R. Opening back up the R. Literally sometimes the easiest stuff. Kayla right there, 50 points. Some big helps, Kayla right there. Helping out right there. And I might remove that in a moment, Kayla, because I think it links to our player. So we'll see if... I'll tell you why I'm removing it in a second. Or Kayla, after she clicks it, since it might link to the playlist, so that way, like, so the playlist doesn't get out there. Awesome, Kayla, if you can remove it. Nope, Kayla, 50 points again. Thank you so much for helping. If you can just hit on it, remove. That in case someone, like, comes across me. Yeah. Can I do it? Nice job, Kayla. Great job. You're right there. You're awesome. No, helping out students. Love it. Huge help right there. And that's going to really help. And watch this. We're going to get this fixed up with this plot. Really? Oh, let's see what it's mad about. It's still mad about the infinities. Why does that not work? So we should be getting it. Is everything not right? Let me... A little bit of work to do on it. Okay. Use the relevant function from looper date to convert. Oh, man. I like my data to be fixed for me when I do this. Okay, let's look at the date. How does the date look right here? How does that date look? It's still mad. It's user error. I'll do this part of it. So how does that date look? What is the relevant function from luberdate? Library luberdate lets us handle dates. So we need to fix that. How do we fix it? What is the relevant function from luberdate? You have to look at it and you have to figure it out. And this one is a great way to figure out what the format is of it. Think that's the this, that's the this, that's the this. So what is that going to be? Ooh, sorry, I just painted my neck. What function is this going to be for this? Luberdate allows us to handle dates and turn things into date objects. So to get this plot right here, we need to fix it. How do we fix it? Year, month, day, yep. Year, month, day. So it's just, this is in year, month. We're going to take and we're going to change it and then overwrite it. That's just going to overwrite it right there. And oh, we get the plot finally. Good stuff right there. We got the plot. And now we need to make a subset. So yeah, let's do these parts of it. Okay, so now we need a subset of the year date greater than, you know what we could do? Brian could try a little bit of his filter right here, right? So let's do it a few ways right here. One, we can go right here to subset of AAPL. And I think we can just add that in. And then that's the conditions right here. Is it going to do it? Might just do it right there. So let's go to sub. And then let's take a look at the subset. And did we do it? I think we've done it. Yep. If you can see right here, this now only has that. So if we have made our subset right here, we could go back and we could replot the subset and we can see, there we go. It's just that the series kind of changes. Can we go over, you bet? We do number 5 here. I think Jack also wanted that one. So 5 would be a good one to do. But does this make sense? We now have this plot right here and we're trying to figure out when it goes down at least 3 days in a row. Now here's the important part of this. We're kind of getting to the later on parts of this. We're just doing different parts, kind of talking about this. We can do a summary right here of our sub and which variable are we doing? Is it the close? There we go. So we have confirmed we have the right subset. Very good stuff right there. Left arrow, the close column in the subset into a vector named close. We can do that right here. And then we need to go through. So we need to take this close vector right here and left arrow it into a vector called close, which is going to stay in the global environment. So there we are as our closed vector, and we can see what's going on. Now, we want to understand what to do right here. I hate these fake messages I get. So what I'm going to do right here is I'm not going to do your full problem. I'm going to change this slightly. Try to think of how I can do a version of this that is not quite your version. When you run this function right here, you're making a trigger vector. And the trigger, once again, similar but not quite same work. And I can always do similar but not quite same work at any time, so watch out. When we make this vector of trigger, we're going to repeat basically like false. And then we want to repeat that maybe 100 times. Not saying I'm doing your work right here, but it's a little bit similar. This is our trigger vector to find out if we want to purchase. Now, let's kind of reverse this right here and think about if we were to sell. You might want, what is it? Buy low, sell high? Oh, no, Mohammed. It's buy low, sell high, right? Buy low, sell high. So if we want to figure out when to sell, what if we wanted to figure out, has it gone up in the last, like, let's say, 3 days? Has it gone up in the last 3 days? Does that make sense right there? Has it gone up in the last 3 days? Let me check YouTube. Where? I'm not in the studio. Did I close out of the studio? We might be streaming problem. YouTube might be weird. Good things happen during office hours, not class. Ah! Let me look at what's happening in the studio. Okay. This happened during class. Okay, we're back now. We're back. Seeing if I can see myself. Okay, it shows I'm streaming again. Yeah, I don't know why YouTube shows me in the studio. I've been getting random errors like this lately. It might be sudden link or something. Thank you, sudden link. We saw an error like this last week, but I'm hoping that we don't get more of these errors. Semester ago, we had a few problems, but yeah, sorry about those errors. Hopefully, YouTube doesn't continue to give errors like that. We don't like that. YouTube, stop it. Or sudden link, stop it. It's probably one of the two, either YouTube or sudden link. Don't love me some sudden link. I might try to get a more, I don't know. Talk about Starlink. If it's stable, I'd love it. So what we might try to do here is we might try to figure out, and this is a similar but different problem. We might try to figure out a way to see, let's call right here, practice data. And I'm only going to use, what is Brian doing right here with his practice data? What is Brian's practice data? I'm doing some practice data right here to see if it works. So this is a similar but different problem, and I'm using some practice data right here. So what is my practice data? Just tell me, like, I'm trying to make a working version of this that's smaller to see if it works. I'm going to, like, do a smaller thing to see if it works on a smaller thing, because then I can just expand it to bigger things. So what is my practice data going to be? Just look at how I coded it. Once again, this is all just practice work, and you just want to, like, code it so it works on a smaller thing. You want to make sure it works. Do it in those. You know what I'm going to say. Don't do the full thing at once. I'm taking kind of a sample of sorts. I mean, it's a convenience sample of sorts, too, because we're taking the first so many observations. But this is time-ordered data, too, so we can't reorder the data. I'm taking the first 10 observations for a practice data set. So what I'm choosing to do is I want to sell is if in the last 3 days it went up once. So I'm selling. My version tells me to sell if it has gone up any in the last 3 days. So this is my version of the problem, tells me to go up if it's gone up any in the last 3 days. So what do I want to look at right here? I want to go to the practice data, and I want to see if on day 1, if day 2 is greater. And I'm going to actually call this PD for practice data, just easier to deal with a smaller thing. Okay, so this tells me if it went up from day 1 to day 2. Nope. There we go. Because if you look at this, it did go up from day 1 to day 2. So does this make sense right here? It is telling me, and Kayla, excellent work, Kayla, following along right there. This is telling me that it did go up from day 1 to day 2. Does that make sense what that is telling me? So make sure, like, look at your data and be like, okay, is this doing what I want it to do? This tells me it did go up from day 1 to day 2. And right here, we're then going to say, we're going to section this off so it's its own thing. And then we're going to say we want to see or, and mine is an or, yours might be an and. We want to see right here, or yours might be an and, hint, hint, hint. We want to see, or did it go up from day 2 to day 3, or, I got another one here. Yours might be and, or did it go up from day 3 to day 4? Does this make sense what I'm looking at? Did it go up from day 1 to day 2, or did it go up from day 2 to day 3, or did it go up from day 3 to day 4? Did it go up for those days right there? Does that make sense? Who's with me on that? Like, that's what my version of the problem is asking me to do. I'm doing a slightly different but similar problem. And then this is giving me one true or one false. It's evaluating to this right here. So we're just seeing, did it go up from day 1 to day 2, or did it go up from day 2 to day 3, or did it go up from day 3 to day 4? Because day 3 would be less than day 4 if it went up. So I know I'm saying, is day 3 less than day 4? But that's asking, did it go up? Like, is day 3 lower because day 4 is higher? Who's with me right here on the logic behind my version of the problem? I'm just seeing, did it go up from day 1 to day 2, or did it go up from day 2 to day 3, or did it go up from day 3 to day 4? And this evaluates to one logical right here. This is more part B, because I think part B wants you to start storing the vector right here, We've done most of part A, I think. So we're going to figure out right here if we should sell our stock. I'm seeing if I should sell my stock. Like if it's true, I should sell my stock because it's gone up over these last 3 days. So I'm going to sell if the stock's gone up over these last 3 days. Maybe I've got a stock that's crashing, and if it goes up over the last 3 days at any point, I'm going to sell it. Does that make sense? So I look and I say, has it gone up any over the last 3 days? And if it has, I sell it at that point. Like that's a sell period for my stock. This is my version of the problem right here. And with this right here, this is going to give us a logical condition. And we're going to go right here and go if. And we're going to put this inside of it. So that's a big if right there. That's going to be our condition. And here's where we make sure we put the right thing. We're going to go right here. And inside of our trigger vector, which I'm only going to bring it out here to 10, inside of our trigger vector, we're going to store into trigger, which is currently all falses. We're going to store into position where? What position will this store into? So what position will we currently store into right here? What position will we currently store into? What position will we currently store into for this? Because what day am I evaluating on? So think about this. You're evaluating on this day because you have to look into the past. So you're evaluating on what day right here? So what day are you evaluating on? You're evaluating this on the blank day right now. So this is telling you whether you should sell on this day. So what day are you evaluating this on? Right now, my code is in this point in time. Like I am currently at this day and I want to know, do I need to sell? So the trigger is storing into it whether or not Brian will sell on this day. Kind of HTT, kind of, well, we'll see that here in a moment. We're not going to code it as eyes yet because we're going to put the eyes here in a moment. But look at where the code's at for the condition. The conditioner has us at currently day what checking this. We're currently at day what checking this. Because we have to look back at the previous days. So we're currently at this day. You got it, you got it. I know you can get it. We're currently at this day checking this. What day are we currently at in time? Day 4. Kayla, I love it, Kayla. Yep, we're at day 4. Yep. And so we're going to store the decision of what we do at day 4 right here. And if we meet these conditions, we will store a true, which means we're going to sell. So we are at day 4 currently because we're looking back on day 3, day 2, day 1 to see if the stock has gone up over these days. And we can see right here when we run the trigger vector now, look at what's in here. It actually wrote true into the vector because it saw that the stock went up at least one of those days, and so we should sell the stock. Now, this is where HTT, you're on the right track right here, because now what I'm going to do is I'm going to code in I equal to 4. So if I is equal to 4, what is 4 equal to? If I is equal to 4, what is 4 equal to? If I is equal to 4, what is 4 equal to? It's conflict. Don't worry. It's just as simple as it sounds. It's equal to I. Then we have this is equal to I. This is I minus 1. This is I minus 1. It's just because it's 4. So 4 minus 1 is 3. And then we have this is I minus 2. I'm just recoding it as I's. And you might say, well, why would you do that? The reason we do that is because I can run the loop now and it runs the same way. We can put trigger outside here to see what it evaluates to. But then I can just change I and then I advance the loop. So now you can see it's stored a true here, and it's just going to advance the loop for me. When I run this code, it's changing those to trues because it's evaluating it. We can see it's probably just going to keep saying I should sell my stock. Mohammed, great answer right there, 50 points. This is our skeleton, so we are confirming this is working. So with this right here, we're actually kind of lucky the way I coded this because this gets around one of the problems people have with the way they code it. I only have 10 observations. And they are turned all to true because it did increase some point in the last 3 days. Mine's a little different than yours, remember. The way I coded mine right here would be 4. And we're going to take this code right here, drop it in the for loop, change our variable to I, because that's the vector we're choosing. No, YouTube. We're back. Sorry, everyone, we're having these little blips. I don't know if it's YouTube or Suddenlink. It's one of the two. This semester's been really good. And actually, this whole year has been really good. It was fall last year that we had issues too. Not big issues, but class today has been good. Little blips we don't like, but so we go right here and we go to our vector. Now be very careful. Yours might not work with this. Do remember, I showed mine worked through 10, and so I can go through the length of we're doing the practice data set. And that should work. And that does work, and it produces that. So with this right here, we've coded our for loop, and we've coded the condition, and then we've shown it worked on a smaller version. It just depends how you code, especially your placeholder. Since I'm coding where I'm storing into position I would start at position 4 because I'm evaluating starting on day 4, and then I'm going all the way through the length of the vector. Just be careful, because if you're doing I+1 or stuff, then you can't go through. So I see a lot of people, I've helped a lot of people because their length, the biggest problem I see right here is someone is doing something like this, because then anymore. Because if you go through the length of the vector, you're outside the vector. So if you were to code like this right here, then what would you have that you would, it would be different. Be careful, this is just showing like I didn't change all this. But this right here, you wouldn't go through the length of the vector anymore, and I can make changes. If you coded it like this, which probably some people have, if you were to code it like this, so if you were to code it like this, which you can do, you can't go through the length of the vector anymore. Because when you're at the length of the vector, you'll be at 10, and the vector, you'll be at 10, which is going to be your I. And think about what 10 plus I is equal to. Remember what the length of the vector is. Right now, my vector is only of length 10. So if I do 10 plus 3, there are no observations here at 10 plus 3. So if I were to run this loop, I am probably going to get an error right here. And that's probably what people see, because there's nothing to evaluate. That's probably the most common error I see, because there is no values here, and it can't evaluate this. Because currently I is equal to 10, unless it stopped the loop. No, it did stop the loop. It stopped it at 8 because it couldn't evaluate anymore. Because at 8, this would be equal to 11. And remember, there's only 10 elements here. We're doing a smaller version of it. Is this making sense? Did anyone figure out their issues? My goal is to help you see how we code the conditions and what the loop is doing. You want to make sure you code your stuff outside the loop to begin with, get it working, and check your conditions that they work on a smaller version, and then put it into the loop. So if we just did the same thing but wrote the condition we need and then make sure it works and then put it inside the loop, little bits, exactly it. I think we had a question on 201. YouTube, be nice to us. Let's see right here. We're going to go to the 201 question was Chapter 6 quiz. Let's do some Chapter 6 quiz. We'll come back here. We'll do question 5. That was the big one that some people wanted. Coming back here in just a second. YouTube, be nice to us. We like you, YouTube. Be nice to us. Or Suddenlink. We don't like you, Suddenlink. So here we are with some Chapter 6. Was there a specific... Oh my gosh. Doing it again. Okay, it's back. Check Suddenlink. Suddenlink says I'm getting 45 megs up. 45 megs up right here. See in the background right there, 45 megs up. I'm even lagging behind on my own stream. Wow, really far behind. Cool. Let's do some Pearson, Suddenlink, or YouTube, whichever one is doing it today. Don't be messing with us. It's 2021. We're still figuring out this whole internet thing. We'll figure it out one day. We'll get good. Tell Chelsea, like, we're getting new internet. Getting new internet. The area we're in just doesn't have good internet options. We're going to do a Chapter 6 question. It's a black screen now. No, 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 no. This is we're live. All right. Oh my gosh. I'm sorry, everyone. It was actually fine during class. During class day, Kayla can report we didn't have any issues. I don't know what YouTube's doing in this moment, but we had no issues during class. And we've been good. We had no issues yesterday. Yesterday we streamed for like 4.5 hours, no issues. But office hours today are just going crazy. So let's hope it stabilizes. Sometimes it just has weird issues and then it stabilizes. Let's hope it's that moment. Chapter 6 right here. Now, with this right here, what do you notice? What are the conditions for correlation? Good practice right here. We'll do 2 questions from chapter 6. What are the conditions for correlation? What are the 3 conditions for correlation? QQ. What are the 3 conditions for correlation? So when you look at this right here, you should think, what are my 3 conditions for correlation? What are my 3 conditions? Make sure there is an HD button. When it comes back, it's not an HD sometimes. QQ, straighten up, no outliers. Perfect right there. Sometimes it's not in HD when it comes back, and there's an HD button right there. It'll restart like in lower def. It's mean like that. So there's an HD button right there. We made that because there was an issue one semester. So the scatter plot is not linear. Correlation might not be appropriate, and that's excellent right there. That is not straight enough. A little bit of a bend right there, so we're not going to see a good straight enough relationship. And so let's do another one right here. That was an easy one. We did the ceramics a lot last. If you think about the ceramics one, we got some videos on that last week. I like this one a good bit. I think this one's good. So when we look at this one right here, we'll do 2 more. So this will be 1 more right here. Correlation measures the what strength between scatter plots. Correlation measures the what strength between scatter plots. It only measures the what strength. Correlation only measures the what strength in scatter plots. Everything's acting up today in my back. Correlation measures the what strength in scatter plots. The linear strength, Kayla, excellent work. So this one is strong and has a what correlation to it. Great job, Caroline, also. So this one is strong and has a what correlation to it. It is strong and has a what correlation. Like this one's strong, but it's also what direction. So negative, exactly. So we're going to go right here. D has to be the strongest negative. Strongest negative is that right there. Now this one is the weakest. What correlation do you think C has if it's the weakest? C is the weakest. So what's its correlation? C is the weakest. So what's its correlation? It's the weakest. That means it must be closest to this. If I say something has very weak correlation, you automatically know that the correlation has to be very close to this. It could be positive, it could be negative, but it's going to be very close to this. Because it's going to be a little negative or a little positive. Hint, it can be a little negative. It's going to be close to 0, exactly. And the one that's closest to 0 is this one right here. And now that means we have to pick between this one and this one for A or B. So which of these is the strongest linear? Is A or B the strongest linear correlation here? Great job, Kayla and Caroline. Excellent work. YouTube, don't fail us now. Which of these is the strongest linear? A or B? Which of these? B. Yep. This is the strongest linear. This is still somewhat strong, but has a little bit of nonlinearity. So B is going to be the strongest linear. And A is still kind of strong, but has a little bit of nonlinearity. As long as you type the numbers in the right way, you will get it. And I think, let me see here. I want to see a different version. Aha. Now this one right here, if you look at it, has a correlation close to 0 because the correlation is not what? It is still associated. That's good knowledge for the test. This one right here is still associated. It just does not have a linear association. So it comes back with the correlation close to 0. Now the strongest one is actually this one. Very strong negative linear correlation right there. So that's going to be the strongest negative. It just goes down. That's the direction of it. This is the strongest positive. And then this one's negative, but a little bit weaker. And this one's just a good practice of understanding the strength of correlation and how something that has an association like this right here could have a correlation that is close to 0, but is still associated because it's not linear. Let's do one more version, then we'll hop back to some. So that's another version of that one. Lots of like, do you know the correlation? This is a good one right here. Different change of pace on it. So this one right here is with hurricanes. Now what we're going to do to the hurricanes to kind of recenter them is we are going to add 120 miles per hour. Question 4, Coraline, if you can mention which one that is, because question 4 changes. So mention which one it is, like put a star to the question, because my question 4 will be different than yours. So put the star of the question, we'll come back and we'll do that after a 474. So drop that in the chat and you'll be the next one after we do question 4 for 474. So just be like, here's the star of the question, and then we'll come back and do it. So when you look at correlation, correlation is a what measure between values. We talked about it a lot today right here. And since it's with z-scores, correlation is whatless. Correlation is based on z-scores. So correlation would be what? Most roller coasters get awesome. We'll do that one after the you got it, Corlin. You got it. That is next after 474. You got it. So right here, we've got it's unitless. Exactly. And what does that mean? It doesn't matter.
It doesn't matter
if we add a constant to it. If the average for the first test is a 70 and you make a 70, what is your z-score? If the average for the first test is a 70 and you make a 70, God, Kayla, great job right there. I love it. Kayla's just on fire right there. I was like, wait, she already answered it? Wow. That was super quick because you're the mean. But what if Brian goes, that's the mean. What if Brian goes and adds 10 points to everyone's grade? What is your grade now? What is your z-score? You made an 80, but if I go and add 10 points, because I just add 10 points to everyone's grades, then what is your z-score now? Now you have an 80, but the average is an 80. If I add 10 points to everyone's grades, your z-score is still a what? So if I add 10 points to everyone's grades, your z-score would still be a what? Because you're still the mean. So you're like, oh, hi, I have an 80, but I'm still at the mean. I'm still have a 0 for my z-score because I'm still at the mean. So it's important to notice right here, z-scores are how we calculate correlation. So if we were to add 120 to the values of like x or y, then the sign of the correlation would do what? What would happen to the sign of the correlation if we had a constant? Exactly, unless you just add it to sum, exactly, then you might go up. Like you get 10 points, then you would go up. That would change the relationship between x and y, because then some people would have higher grades, like which whatever metric we're measuring. Good answer right there, Kayla. Unless we just added it to sum, because then it wouldn't be a constant. This one is a constant add though. So the sign of the correlation would do what? Because it's based on z-scores. So if we just add a constant to everyone's grade, or constant to this right here, add 120, the sign of the correlation is going to do what? It's not going to change. Nothing. And the magnitude of the correlation is going to do what? Because it's based on z-scores. And z-scores are not going to change. So the magnitude of the correlation is going to do what? Which is how close it is to -1 or +1. If you're wondering what magnitude is, that's basically strength. They should have just said it in the strength. They should have just said strength. That's what magnitude is. Like closer to -1, +1. So they're saying the sign would not change, so it wouldn't change positive or negative. And the magnitude is going to do what? Not going to change either. Because the what's that it's based on, the z-scores upon which the correlation is based on, does not change. So right here, our correlation is calculated from z-scores, and the z-scores don't change. So nothing about the correlation changes. I think our apartment's haunted. Let's go back. We're going to do some 474, then we're going to come back to 201. We got tons of time today. Let's go check it out. As Brian just sits here in his haunted apartment. Scary stuff in the haunted apartment. Question number 4 for 474. Let's go take a look at it. Question number 4 for 474. Right function called cosine difference. Let's go check it out. Here we go. Question 4 for 474. Homework number 3. Write a function called cosine difference that takes 2 arguments. Must take x1 and x2. And we've got 2 vectors. The function should return the cosine difference between the 2 of them, which is the following function. Woo, it's a big function. And and then let me see right here. Okay, that's ridiculous. For example, here we go right here. Something looks odd about this. Like something looks way too. Yeah. Showing it. This right here. Don't write the full function. I'll write a little bit of it right here. Okay. So the way in which this works is you've got your x1 element, like your vector x1, element 1, vector x1, element 2, vector x1, element 3, and vector x2 element 1. Wish I could do a subscript right there. Vector x2 element 2. Okay. So what you want to do is you want to try writing this out in little bits. So how could we get this right here? You have to watch out. This is a little trickier than it looks. So what is the mathematical formula to get? If we have two vectors, we take a vector like x1 is equal to this right here, and x2 is equal to this right here. Sure, why not? So here's our vectors. How do we then solve this component right here? That stands for x1 first element times x2 second element plus x1 second element times x2 second element plus x1 third element plus x2 third element times x2 third element. How would we solve this right here? We have to be very careful. We're going to translate that into code. Is there a minus on that? That shouldn't be a, there it is, equals. Like, why is that a minus? Oh, it is an equals. Just look weird on my screen. How do we translate this into code right here? How are we going to make that code? The easiest part is the multiplication of vectors, and then we're summing up the multiplication. So I just said it. So I just said the answer. We are summing up a multiplied vector. We are summing up a multiplied vector. That's the answer to it. So we are summing up a multiplied vector. We are summing up a multiplied vector. David and Melanie here. We'll put it in the chat real quick. We are summing up a multiplied vector. How do we sum up a multiplied vector? How do we sum up multiplying vectors? How do we do that? So we need to think how to sum up multiplied vectors. How can we sum up the multiplication? Because that's what that is. You just look at it right here and say, oh, you are multiplying pairwise multiplying vector. Well, we're going to sum it. You're right. We're going to sum it up. And then what do we need? We're just solving this component. We're only solving this component. Remember, we're doing this in little bits. We're not going to write the whole thing, because if we write the whole thing, there's going to be an error. So we're summing up the multiplication of a vector, which should give us one number, because that right there is something times something plus something times something plus something times something. And it'll do it pairwise, which will do it for us. It'll do the pairwise multiplication of vectors. Hopefully they're of equal length, which is one of our goals for this. So how can we sum up the multiplication of a vector? And that's kind of the answer. I'm saying it. How do we sum up the multiplication of a vector? Because that's the sum of the multiplication of a vector. The sum of the pairwise multiplication of a vector. So how would I do it with my code right here, my practice code? So if you think about this, yep. And mathematically, you should check what you're doing. Mathematically, we should get 15 plus 4 plus 8. So we should get 27. There we go. Why am I saying that? Because 3 times 5 is 15. 2 times 2 is 4. And 1 times 8 is 8. If you want to make your life easier, change this to like 1 right here. And then it's 3 plus 4 plus 8. That's going to be 15. So now if we resave our vectors, we get 15. Did I say that? I should have 3 plus 4 plus 8 is 15. So just you're getting the pairwise multiplication. The next part of it right here is taking the square root of raising the first vector. I think this is the first vector we used in an example. Because saying here's the first. So that's the square root of the first vector. The square root of the sum of the first vector. So the square root of the sum of the first vector squared. I got to be very careful with my words. The square root of the sum of the first vector squared. So go backwards on that. So you ready to listen to it again? The square root of the sum of the first vector squared. So what's the first thing I should do going backwards? So listen to it again carefully. The square root of the sum of the first vector squared. So go backwards when you make your equation right here. The square root of the sum of the first vector squared. Going backwards, you're going to first code what? The process is what matters right here. So you got to practice the process. The square root of the sum of the first vector squared. I think, and then first vector, and then we'll do second vector. Because then we're going to times that by the same sort of thing. So Mohammed, exactly right there. You're on the right track with that. That's what we want. we want, and we'll just do it as a component of this right here real quick. It's going to be the square root of the sum of the first vector squared. And let's see if it works. It does work. And then we're going to do the same thing, but with the second vector. And then we need to be careful where we put our things, because this is going to be divided by, and we want to open this up, this times this. Notice I'm putting a lot of space right here so we can see everything's in the right spot. But it's mad. It's no longer mad. So when you look at this component right here is this. That's that first component. This is this component, and this is this component. Make sure you have a parentheses on it such that it is all evaluating, and then I'm going to throw another parentheses around this, and what am I going to put before all this? Because that's all going to evaluate on its own. What am I going to put now? What am I going to put now? What am I going to put now? Because there's one last thing I'm missing right here. One last thing I'm missing. Look at the equation. So what am I missing? And then I'm going to see if it works by doing some sanity checks. I'm actually going to run it with a sanity check. Missing one little thingy. Look up here. What are we missing? We have not put this onto our equation. So what are we missing? Always remember to do these in little bits. If you try to write the whole thing, you don't run it. We could store it, but this is not the right equation yet. And we can see that it's not the right equation with the sanity check. So we've got right here a vector that we can run, and we should be getting 0.08. So, yep, you got it, Mohammed. So we don't get the right answer right here, and you can actually see it's the complement of this, some Stat 1 knowledge. By taking the complement of this, we will get the right answer. So this does confirm we've written it the right way. Does that we go through, we just make sure we got this written the correct way, so our equation is solving correctly. I took the numbers down here used in the sanity check to make sure I'm getting the right answer. So this tells me right here by putting these in as my vector 1 and vector 2 to practice with that I am getting the right answer. So this one was a lot of like exactly how to do it. From here, we pretty much need to make this into a function, and we probably want to store this into the object D, or lowercase d, whichever one you want. And I like to put my parentheses. I love parentheses. Parentheses, those 100 points go out to you for being parentheses. Then we need to go and make our function. I'm going to stop right here. But the function is going to take the inputs. I mean, not times, but you know, the inputs. The function is going to take the inputs, and then you need to check for your warnings. And you probably need to do things like check the length of your vectors to make sure you're getting the same length of vectors to be able to do this right here. Once the function works, then comment these 3 lines, make sure it works. And good stuff right here. Custom warning right here, all this good stuff. Make sure you get that custom warning and check this out. Is this making more sense, Mohammed, on how to do this one? Basically, you want to input your arguments right here into the variables. And then you want to call it a name. So you just want to go over here, take this name and run it like that. Make sure to store it in the right name. And make sure, once again, when you do your functions, just type fun for the snippet. It's very easy to make errors when you do this and not use the right things by typing it yourself. Much easier to just use these snippets it gives you, and then you get the right stuff right there. How's this looking? What are people thinking on question 4 for BAS 474? I think this is a lot of good help on this one right here. Like, I don't want to do the full thing, but the turning of the equation right here, and once again, make sure you check it. If you're not getting the right answer, like with the example, if you're not getting 0.08, then you've written something the wrong way. And don't try to copy, like, I know it's so easy to just like, I'm just going to copy what's written on the screen right there. But you want to try to go through the steps and build it in little bits, because no one goes and just writes the code flat out by like starting right here and writing through. You're going to write little bits of it and be like, okay, we have to sum this vector. Here's that component. We have to take this component right here. It's the square root of the sum of the squared vector. This one's the square root of the sum of that squared vector. So turning it into code, the square root of the sum of the second vector squared. But all these things right here. So how are we looking? 201, we're going to hop back to some 201. Looks like we're doing all right. So I think this is some good help for question 4. Gets people started. Good stuff. Remember, practice, practice, practice. Let's head back to the main screen here. Let's do this. I think it was some roller coaster questions next. What was it on? The next question is from Corlin. So we got here, most roller coasters get their speed. Let's go check out that 201 question. You're welcome, Mohammed. Thank you so much. I'm glad it helps. I want to get enough of it done that it helps, but doesn't do the full question. Like, I don't want to do the full question. I want, like, to get partially done right here. Let's do some 201. We'll do a few more correlation questions. This one's the roller coaster speed question for 201. Let's go check it out. Chapter 6, roller coaster question. Does the scatterplot indicate that it is appropriate to calculate correlation? QQ, two quantitative variables. Straight enough. It's straight enough. No outliers. These, if it calls these outliers, I'm going to get mad. These are not really outliers. It's just points that are a little further away. 320 might be thinking a little heteroscedasticity. Little bits. Heteroscedasticity. Little bits. Nothing too crazy. It's mostly good. It's about as good as you're going to get with correlation. It's actually really good. You're welcome. Yeah. Mohammed, that's exactly what I want. Mohammed, 100 points goes out to you right there. It's tough. It's like I gotta walk you up to the knowledge cliff and say, you have to fly. And you're like, I'm not ready. And I say, you got this. You got this. Jump off the knowledge cliff. I mean, no, you got this. You're going to fly. Trust me. So does the scatterplot indicate that it is appropriate to calculate the correlation? I'd say yes. It shows a, what do we need for correlation? QQ. Straight enough. Scary Cliff, you got this. You're a bird. Take those wings out. Fly. Because this form right here is mostly what? What form do we use for correlation? Mary, you got this. What form do we use for correlation? You got this. Fly. What form do we see for correlation? The form we see is linear. Correlation, you got this. It's mostly linear. QQ, straighten up. No outliers. That's what we want to see right there. These are not really strong outliers. I know it's like, but usually we're going to see further away outliers. Watch me get one wrong. In fact, the correlation is this. That's a very strong positive correlation close to 1. Describe the association. Well, that's going to be strong, so it's between one of these. Positive. Ooh, look at that. Boom. Strong positive. I think we got it. You flew. You did it. Zoe, Mary, Coraline, Corlin. So Coraline and Carolyn together there into the movie Coraline. Still haven't seen that movie. Need to go watch that. Hey, that's a good Halloween movie, right? We're watching some Halloween movies. Saw one this weekend about something Winchester House. Winchester House we watched this weekend. So I picked up groceries during it, so I missed some of the movie. Let's go do another 201 question. So let me put a little break here. I got to put this in. It is so Coraline's so good. I should watch Coraline. I really love. If you want to see a good movie, which is it's Halloween related, right? Watch Corpse Bride. You're like, Corpse Bride? Who wants to see a movie called Corpse Bride? Who in this chat has seen Corpse Bride? Because I'm telling you, watch Corpse Bride. Beautiful movie. Amazing music by Danny Elfman. And Tim Burton doing the movie himself, I think. Let's do, you want to do the Ceramics Factory? Let's do the Ceramics Factory question. But check out some Corpse Bride while we're here. So check out that movie. Awesome movie. Great stuff. Let's go do some ceramic. Yeah, it's awesome. I know, I thought everyone's seen it too. It's such a good movie. I saw the movie in theaters. I'm old. Great movie right there. Check it out. Okay. So for this one right here, yeah, it's such good. I play it on piano sometimes. I love it. So this one right here, we have a scatter plot, which is what? 2 quantitative variables. And then we have here histograms, which are 1 quantitative variables. Now, this gets tricky because it wants you to find the histogram related to the scatter plot. And I'll tell you the truth, first semester I was like, what? Mark, we could do that here in a little bit. You got it. So take a look at this. We want to find out the number of broken pieces. So we're not going to look at batch number. Don't look at batch number. For this problem,
It doesn't matter.
batch number doesn't matter. I'm not looking at it. Don't look at that. Don't look at these numbers. We're just trying to figure out the univariate relationship by looking at one variable. How many times are there 0 broken pieces? Just take it here. Watch how this one works. How many times are there 0 broken pieces? So I just want you to look at this graphic and tell me, how many times are there 0 broken pieces? 4 times. Does that make sense? Oh, we did 3 earlier at the start. Check out Roger. We've covered 3 a good bit. 4 times. Whoa. Brian is showing you how many times there's how many broken pieces over here. That's a lot of times. I'm showing you how many times there's what. Don't look at that variable. There's 7 times that there's one broken piece. So we have 4, 7, 5, 3, 2, 2, 1. I'm just looking at one variable. I'm just looking at how many broken pieces there are. So there were 4 times 0 broken pieces, 7 times here, 5 times here, 3, 2, 2, 1. This is just one variable. I'm just looking at the broken pieces. 4, 7, 5, 3, 2, 2, 1. 4, 7, 5, 3, 2, 2, 1. 4, 7, 5, 3, 2, 2, 1. That is the amount of broken pieces when we look at the one variable. So we have confirmed that this is the histogram for broken pieces, ignoring batch number because this is a bivariate display. So describe the distribution or the shape of the distribution of the histogram. It should say shape there because histograms we can look at shape. So right to the high, left to the low, whatever way the tail goes, this distribution is very, very what? Right to the high, left to the low. I mean, it's moderately this. Right to the high, left to the low. If there's a test question like that, you're like, psh, I got it. Right to the high, left to the low, whatever way the tail goes. Right skewed. This is when, like, these questions right here, if you get to them, you're like, that's the easy stuff. Then you've done it, and then you know it like that. You learn right to the high, left to the low, whatever way the monster main's tail goes. So we see right here. Now, you might have a uniform one. Look at yours. Yours could be kind of uniform, like flat. If yours looks uniform flat, make sure to answer that way. If it's got a tail, make sure to mention the skew of the tail. So we see right here, this is right skew. What feature of the problem is more apparent in the histogram than in the scatter plot? So histogram is going to show us shape, center, spread. So we can see the shape of the distribution, that there is a skew to the distribution. We do not see the bivariate relationship in the scatter plot, though. So this is going to show us I know, right? No, Mohammed, you see the evolution of how I teach 201 over the last 2 years or so. Right to the high, left to the low, whatever way the tail goes, and I just draw my monster man. It's the new thing. Yep. Love it, Mohammed. Seen the new additions. So what aspect of the company's problem is more apparent in the scatter plot? Now, the scatter plot is going to show a bivariate relationship up here. Now, what do you notice is the direction of the relationship? What do you notice is the direction of the relationship? As batch number increases, we're seeing what to the number of broken pieces? As batch number increases, it's a positive relationship. So this is saying, like, as we make more batches of ceramics, they have more broken pieces. So it looks like maybe later in the day, people are just not working their job as well. I don't know. I don't know what's so bad about our workers. They're doing a good job. We appreciate you workers, but there is a positive, somewhat linear relationship where we see that as batch number increases, we are seeing more pieces broken because a scatter plot is going to show us strength, direction, form, and unusual features. This is a somewhat strong strength, positive direction, form, mostly linear with no outliers. Unusual features would be outliers. So good practice right there. Really great questions. I think question 5 is next. We can go back to 201, or then we're doing some 475 after this. So let's go do that 474 question 5. Take a quick look at it. 201, be asking those questions. We got time for a little bit more after this. Let's go check it out. Gonna do another 474 right here. Let's go check out 474 question 5, and then we'll go do some 475 and 201, be asking questions because we got some time. Right function called leaps. Let's go check out 474 question 5. Let's go check it out. And Kayla, amazing work today. Kayla answering the 474 questions. Another 50 points goes out to Kayla. Thank you so much. I love it when 201 being like, I can do that. I can figure that out. You got it. Let's check it out. 474 question number 5, homework number 3. Where we're going to write a function called leaps. Have the function return the vector x leaps defined as the absolute value of the difference between the x elements separated by a lag element. You're welcome there. Excellent work. So we got right here a vector. And when we do leaps, it sounds more complicated than it is. And we're already storing it. Cool. So when we do this right here, we have to think about what we're doing. The way leaps works is if we tell it to do lag 1, it's going to go right here. And what is the leaps for lag 1 right here? I want people to tell me what is the absolute value of the difference between those two values. So not a complicated question. It sounds like a lot. But this is looking at those two numbers. What is their absolute difference? Just like a positive number, what's the difference between those two numbers? So what is the absolute value of the difference between those two numbers? And this is leaps 1, because we're just doing one leap forward. So what is the absolute value of the difference between those two? And then we're going to do it in code. We just have to know what we're doing first. So look at those two numbers I've highlighted and then think of what is the absolute difference between those. You have to be like, okay, wait, 5.1 and 4.9, what's the value of the absolute difference? Just how far are those numbers apart, and only think of it as a positive number. So that's all I'm asking is like, let me make it simpler. How far are those two numbers apart, and then just in terms of positive numbers. How far are those two numbers apart? And just absolute value of that. For example, if I had 8 and 3 or 2, then the leaps would be 6. Or if I had this, it would also be 6. So when you look at these two numbers here, what is the absolute value of the difference? So up here on my example, it would be 6. It doesn't matter if it's positive or negative. Rock, you know the answer.
It doesn't matter.
So it would be 6 here, it would be 6 here. So what is the absolute value of the difference right here? Who knows? 50 points on the line right here. Who knows the absolute value of the difference? If we were to look at the absolute value of the difference between those two values, it'd be what? Might be a really quick way to do this. While you're thinking that over, I'm thinking of a really quick way to code this. The absolute value of the difference between those two. Sometimes I'm worried if no one responds, like, are we still streaming? It wouldn't be 5. That's the average of the two. Good guess right there. Worse than 50 points still. It wouldn't be 5. So it wouldn't be 5. That's the average of the two. So remember right here, this one would have leaps 1 is 6. Or if I change it to something like... So what is this right here? We have to know what we're finding first. What is the leaps of this? What is the leaps one of that? Great job, Roderick. You got another 50 points. It's 0.2, and that's actually the answer down here because we're using leaps 1. So the difference between here and here is 0.2. The difference between here and here is 0.2. The difference between, I just skipped one, here and here is 0.1. The difference between here and here is 0.4. It's just absolute value. It doesn't matter if it's positive or negative. It's absolute value. So you can see the difference between the last two is this. So what I'm going to do is I'm going to take and I'm going to store into test 3, or let's do test 3 underscore 1. And we're going to take test 3 and we're going to store into it let's store the start of it. 1 through the length of test 3 minus 1. Okay, see if that worked. Okay. All I did was take off the last element. Does that make sense? That's a lot of code right there to just take positions 1 through the length except for the last one. So Roderick, does that make sense what I've coded? Is I've gone 1 through the length minus the last one. So I'm taking off the last element. I can take off the last 2 elements if I want doing this. So that takes off the last 2. I can take off the last 3 elements if I do this. It's just how many... I want to go 1 through the length, but go backwards. Like I'm saying, go to the length, whoa, bring it back a little bit here. Don't go through the full length of it. So that's why I'm putting that -3 at the end of there, so I can kind of control where the lag is. Maybe I'll show that. Let's do that. That's my lag. And we're going to store in here into lag 1. So now we are going everything but the last. So we can put that there. That's a big hint. So now I need another vector. And this is my version 2 of it. And this one will go through the full length. But this one is going to start later. It's going to start at 1 plus the lag. We need to section that off right there. Make sure you use your parentheses. So this one's going to start later. This one won't start. think about what we're going to get. It's going to start 1 later because we're going lag 1. It's going to start on element 2 because lag is currently 1. So it starts on element 2. So this vector I'm creating right here is starting on element 2. So right here, this one goes from 1 up to the length minus 1. And this one right here starts at element 2 because it's 1 plus the first element plus 1, the lag. And then it goes all the way through the length. So we get here 2 vectors of equal size length. It's just that the first one ends 1 early, and the second one starts 1 length. And now what can we, 1 late? We can go right here and subtract the 2 vectors. Does it matter how we subtract them?
It doesn't matter.
Nope, because we're going to take the absolute value, and guess what we get? And guess what we can do? We can change the lag on this now, and we can get another answer. And this is confirming right here that we're doing the work correctly. We can see that we are getting the right work right here because we are getting the same values, and we are looking right there, test length, test minus 3. Whew, that's a pretty crazy one. But this right here, when you think about it, is the inside of our function. The inside of our function is going to use this right here, and it's going to return this value. So I'm kind of dropping some hints right now. The inside of our function will return this value right here, and it's going to allow us to augment the length, and we'll input 1 vector. So you don't have to, this will be made for you in your function, this will be returned by your function, and the inputs right here will be the test vector and the lag vector. Does that make sense? A little bit of hints on this one, but that's a good start to it here also. Getting the leaps function right here, and we can confirm we're getting answers. So notice also that we are confirming we're getting answers, and now the job of this is to put this into a function and get it to work, that we call it the leaps function. So once again, delete your work afterwards, but we're going to go down here. We're just going to call it the leaps function. I always copy paste just to make sure I don't make typos. Very easy to make. We got the leaps function there. We need to think about our inputs. We need to think about if we need certain warnings to see if we have something, we've gone leaps longer than our lag longer than our vector. So we need to make sure we have our warnings right here, and we can do a lot of different stuff. Well, let's check out some 475. Yeah, I mean, oh, it's so easy to make typos. So easy. Let's do a little 475 and 201. We still got time. Still got 25 minutes. Let's go back. Let's get some 475 up and going. Look at that. The stream is working fine right now. We got 12 people watching. Say hey in the chat. We got 1 like. Smash like if you want, or smash dislike. Don't smash dislike. Everyone smashes dislike now. But say hey in the chat if you want. We got 12 people watching. Gonna do some 475. We still got time for more questions. I think we're open on questions after this. I always try to make sure we try to do it in the order. But I'm going to be releasing another 475 group assignment for the following week. So let's go check this out. Private release later tonight. I think it was 475 question 6. Mark and Caroline, good to see you. Here's some 50 points saying hey in the chat right there. Question 6 for 475. Oh, got some fun stuff right here. Might do this one in full because there's a lot of work for 475. Let's go check it out. Here we go. Question 6, 475. Are you able to kindly do? Maybe try. We just did Q. Wait, which one? Question 5 on. Were we doing question 6? Question 5 is. Was that not question 5? Was that not question 5? Am I going crazy? Am I losing my mind? Probably losing my mind. All the bright lights. Bright lights. Let's go check this out here. 475, question number 6. No worries. Plot the annual natural gas consumption by state for the New England area, comprising the states of Maine, Vermont, New Hampshire, Massachusetts, Connecticut, and Rhode Island. Now, the biggest thing to remember is we're creating TISBOLs. Might do a lot of this one. We're using the US gas package right here, so we need to install US gas. So make sure to install packages US gas. Make sure to delete this afterwards. If you do not delete this, you'll have problems. You won't have a good time. So I've already installed this, so I can go to library and US gas, and there it is right there. So this is the gas consumption. Cool. I'm done with this one. Create a TISBOL from US total with year, all that good stuff. So let's go here to US total. Take a look, and here's the US total. I think it's currently a TISBOL. Ooh, I don't like how it shows all that. That's a lot. Oh my gosh. Wait, 2 seconds. Clear it out. Then take a look at it. Is it a Tisbol right now? I think it's a table. Oh, it's not a Tisbol. It's not a Tisbol. Tisbol is a time series Tibble. Tibbles are dplyr tidyverse tables, kind of like a data table. So one thing we could quickly do right here is we can pass this through with the pipe option. I did Control-Shift-M for a pipe right there. No worries. No, that's all right. You crack me up, Roger. Good that you and Cooper are seeing each other. I can't wait to see everybody. I hope to be flying in very soon. Get to see everybody and say hey. Then actually go to my office. Be like, welcome to Brian's office. No one's been here for a very long time, except for Janice. Yep, question 5 makes you turn into a Tisbol. So we can do that right here. We could make sure it's a Tisbol. So we can go as.tisbol. Watch me make some errors right here. I don't even know how to spell. What? Oh, you know what I don't have? Ooh. I restarted my R. Common question. I don't see the function. So here we are as Tisbol. There we go. So this should pass it through. Oh, it's very, very mad. Because we don't have an index. Please specify an index. Good comments. One of you go how to tell me a scatterplot shows just association. Yeah, let's do it next. You got it, Kayla. Excellent question. So what do we need as the index in this? Let's go take a look at our data again. What should we use as an index for US total? Really? Where'd it go? US total. I think it's in the global environment. Yep, great job. Index is year. So we're going to index. You can concatenate. I saw people concatenating this. You can just call it year. We're not doing 2 indexes. And then we need key is going to be state. Now, why, and this is a good question. Some people have made why is y, and what is y called? So year is the index. Excellent job, Mark. State is a key variable, a key variable. There can be more. But what is y? I think it's what we're, it's a hint. It's what we're kind of looking at and starts with an M. Y is the what? What do we call it? So we have the index, which is the time order variable of it. We're going to make some scatter plots here, the measured variable. And we can have more measured variables. You can have more key variables. You should really only have one index variable. So now, oh, look at that. We get the Tisbol. So now it's telling us this is a Tisbol, and it's even specifying to us that state is the whatchamacallit, state is a key, and state has 53 levels. So we probably have like territories and stuff like that and DC. So I think we're pretty good right here. But what we could do, I bet we could do this right here. Now that we have as a Tisbol, I'm betting you, we could go to filter, and on the filter, we can go to state equals, and this is where we get into the niceties of using dplyr. So if you notice right here, we're going to take and just copy paste and put everything in quotes because they are strings. And we're just going to copy paste this. And then we're going to make sure we get what we want. We need to take out that and because that's not part of it. That's going to become a comma because that's how code works. We're going to make this look all pretty right here. There we go. Looks a little bit better. Much easier to read what's going on. And then we're going to filter this. We're going to run it. Ooh, it's mad. It's mad at this. Let's go ahead and save that Tibble. Let's go here and save it. I like to write error outside these sometimes. Let's call this data. And there's our data. And now let's go here. And data's not going to want to filter for us. What are you doing, data? It's mad. It's always mad. Filter should be working. Filter on the dplyr. Did I misspell state? There's a little fly in here. We should be able to filter on state. What am I? Oh, wait. No. Oh, it does it differently. It's a little bit different because it's a logical argument. This is where your knowledge of sometimes things conflict. If you go to subset, the subset argument, the way it works, we could probably do the same thing, but this condition right here would look a little bit different. It'd be contained in. It might work the same way. And we could check. And we could check right here. Does it keep it as a Tisbel? Ooh. Check 2 is a little bit different. Making sure we get the right stuff right here. We only get those data points. Okay. Make sure. Let me look at check 1. Something weird's happening. Oh, because it's... We might need to do this. There we go. That is making sense. Yeah, that's an error right there. It's the filter's the same thing as using the subset. I hope I got to make sure I message that person. Always look at what you create and think if it makes sense. The reason I want to mention why, and it was apparent to me when I saw the pattern, the reason this isn't working properly is because it's checking the first observation to see if it's Maine, the second observation to see if it's Vermont, the third observation, there's a little fly in here, the fourth observation to see if it's, does that make sense, Mark? This is not doing it properly because it's seeing if it's equal, so it'll go and look at the first state, see if it's Maine, the second state, see if it's Vermont, and it'll only select it if it's logically equal to that. So we don't want that. We want to choose the ones that are contained in. So the contained in is the actual way to write it right here, not the percent, not the equals, because the equals does a pairwise comparison. We want to see if the state someone gave is contained in the vector. It's always the smallest error. And then look to see if you get what you want, because it's very easy to make mistakes, especially with these. And the select, I was thinking about select. Select has the equals. There's a lot of syntax to remember, and sometimes it jumps out of my head. So right here, we do have this filtered properly. Let's call this New England states. Now that we have New England states, we should be able to, it should like this. We should go to the auto plot, and then we have our Y variable, right? Oh, it's mad. Oh, now this error, the color palette is an error where I need to restart R. So this color palette error, which I've seen before, I'm pretty sure is just a restart R error. So we're going to quit out of here, and then we're going to restart R. So if you get that color palette, so not just autopilot, yeah, autoplot, yeah, autopilot. Pretty much just on autopilot right now. That color palette error is one that is usually autoplot. I mean, is usually that error with the color palette usually is fixed by doing, and watch, it's gonna work. It works. I've ran into that error right there is probably the worst and most annoying, because when you run into it, it's like, how do I fix this? And then can we just pass this through? And look at the beautiful graphic we get. Great graphics, minimum effort right there. And probably what you want to do, and this is good practice, I think I mentioned to label some of these. Probably what you want to do, you could take a picture of it, but then you probably want to pass it through. Is ggtile going to work? It's mad about that. We want to save the object. Let's save the auto plot as object M. And with object M now saved, we're then going to add to it. See, I was making this error so many times. I keep doing piping it through, and it's mad about that. Let's save it to object M, do it in little bits, and then let's go to object M and add to it a GG title, and there we go. And then I can never remember the syntax to get it centered. I always, minimum effort. This is minimum effort right here, Kayla. And then we can pass this through to the ggplotly. Like, I'd pass it through after this into the ggplotly. And that should, oh, it's still mad. We're going to save it into M2. And then we'll pass M2, or we'll do ggplotly of M2. And that should be fine. And now the hello's on there. And so we can get a really great graphic. And what's so cool is this is a web-designed graphic that allows us to kind of remove stuff and zoom in on anything we want. So we could go here to just that series right there and adjust accordingly. and look at everything and look at the Y variable of interest. So it's really, that's one of the great things about using this software package is that if we get good at making these plots, we can make some really great graphics. Not too hard, not too hard. Mark, what are your thoughts on this? We got time for another question from 201-324-74. But Mark, how do you feel about like making these graphics? Like I think so far you got some pretty good tools in your toolbox probably on graphic creation, a little bit of ggplot and a little bit of Plotly right here. It's very easy to make mistakes. Like, awesome. Great job, Mark. But this is how we do this one right here. So kind of giving away this one a little bit. But it's very easy to make mistakes. Just keep looking at what you're making. And it's funny. Sometimes when I make a mistake, my brain just overheats. And I'm like, I'm not going to figure it out. Everyone's going to think I'm crazy. What questions are there? Your time to ask questions. Let me know your questions. Let's check this out. It's always a small error, right? It's always like you forget a percent and percent, or you forget like a pipe option, or you do a pipe instead of a plus, or you forget a comma, or you forget a parentheses. The smallest errors are the hardest to see. And as you get better at coding, it's so many. Hey, what's up, Parker? Good to see you here. What questions do you have? It's open floor for questions. Parker, I hope you had a great community day yesterday. I had a lot of, let me delete and block that message. I want to block this person. I get those random. Go. Parents sent me a video. What parents sent a video of? What is? I don't know. Weird parents. Can you go over number 5? Yep, we can. I'll do a little more review of it. Let's see. I'm going to go to number 5. We did number 5 earlier. Let me see what I can say on number 5. We did number 5 earlier, so I'll try to like talk about it in different ways. Where is number 5? Where is it? Question 4. Question 5. We did it, right? What was it mine? Leaps. Okay, let's review question 5. Here we go. Let's go talk about the leaps function again. And let's go talk about how to do it. Okay. So the leaps function right here. Let's go talk about the leaps function for question 5. I was mostly busy. Hey, Parker, don't worry. Parker, when I come back to campus, just ask for one of these shinies. It's all yours. Just give me a Pidgey. Like, you know, that's how I roll. I think I got a lot. I got a lot. But, yeah. I was reviewing at night, but in the morning, I was like, I'm going on a Pokemon walk. Let's check out question number 5 for 474. Taylor, you got this. Quiz 6, associations on scatterplots. Yeah, here, I'm going to do 5 minutes on each. So for this one right here, so this is a quick review right here, Taylor. We did this earlier, too. So this is a quick review of it. When you're doing your leaps function, I might just show it. Okay. This is the work we did earlier, Taylor. So if you... Sorry, since we're running short on time, and I'll be teaching it a little bit. This is the work we did earlier to talk about how the leaps work. But I want you to think about this. You ready? And so check the earlier part of the video. When you look at these two numbers, what the leaps function is running with an argument of leaps equal to 1, it's finding how far apart these numbers are. So what is the value of the absolute distance right here, Taylor? What is the value of the absolute distance between those two values? That's a leaps of 1. So the value of the absolute distance between those two numbers would be what? Like, if you subtract those numbers and look at the absolute value, what's that going to solve to? So the absolute value of the difference between the two numbers, what will that solve to? Thank you, Parker. The absolute value of the difference will solve to what right there? Well, so think about this. You're going to subtract 5.1 from 4.9. So you would just take these two numbers, and you're going to subtract, and it doesn't matter.
It doesn't matter
if it's positive or negative. You're just going to find the absolute value. Does that make sense right there? And then, great job, Roderick. Yep. And then what about if we do the next one? For the next one, because we're just doing a vector of the absolute value of difference between the next element and the next element. So this will be 0.2 also. And then this one right here is going to have a value of the absolute difference of what? What is the absolute difference between those? What is the value of the absolute difference between those two values? The value of the absolute difference. The absolute difference between those two numbers is what? 0.1 exactly. And then this one right here would be what? 0.4. And because it doesn't matter if it's positive or negative. It's just how far are those two numbers apart in terms of absolute value. And then this one here is also 0.4. Now, if you do a leaps of 2, we have right here the leaps of 2 is saying how far apart is this number, ignore the middle number, from this number. So ellipse of 2 would assign what value right here? We're saying how far is 5.1 from 4.7? So the absolute value there would be what? How far is 5.1 from 4.7? How far are those numbers away? Don't worry about the middle number. Don't worry about this. Don't look at that number. How far are those two numbers away? 5.1 to 4.7. Absolute value of the difference. Don't worry if it's positive or negative. Just be like, oh, they're this far apart. Exactly. So then we would go here and do the next one, and we'd find 0.3. That's where that comes from. And the next one here, and we find 0.3 because that's how far these numbers are apart. And the next one has a pretty big leaps because this one has 0.8 when you look at this. You could do leaps of 3, which is 3 ahead. And then this would be 0.5. This would be 0.1. And then this would be 0.7. Does that make sense where these numbers are coming from? And we did some of the mathematics earlier to show this. So check out the earlier part of the video where we walk through how we made those equations, and then we need to make the leaps function. But that's the theory behind what we're doing, like how these answers down here are being solved. So we need to then write equations, which you'll see me writing earlier on step by step. It would take a little more time than we have right now to write out the step-by-step solve of this. I will label the video later, but it should be about 15, 20 minutes ago. I think it's what we did right before we did the 475. So you'll see a break in the video, but it's about 15, 20 minutes ago. You'll see me starting this. So check that out. You can rewind the video live, and I will put it in later, and we can come back and review this at any time. Yes, and then I missed one of the questions on my first time. So then let's do some chapter 6. Let's go check that out. Which chapter 6 question did people want? So it was, Kayla was asking, wonder if you can go over how to tell if a scatterplot shows association just by looking at it. Scatterplot shows association just by looking at it. Well, how does the start of the question look? Scatterplot shows an association just by looking at it. Is it? I think it's this one. I think it's this one. This one's a tough one. Associations on scatterplots. Is that how it starts? I think I found the question. Let me ask you, yes or no. Is it this question here? Is this the one people are looking at? This one's a fun one. This one's a good one. Yep, it's this one. Let's go check it out. Here we go. So the first thing you want to do with this is look at these. Now, there's a lot of versions of this. I think we can do 2 versions with the time we have left. You want to look at these scatter plots here and say something. Is it positive or negative? Let's first talk about the direction. Positive. Negative, positive. That still goes up. Next, that's the direction. Let's talk about the form. This is a line. That's a line. That's a line. They all follow a line, so they're all linear. Now, which of these is the strongest? This is very strong. This is very strong. And this is like moderate-ish. And I think that's it. We've described them now. Are there unusual features? I don't see any outliers. So when we look over here at the questions, I'm gonna make it small if I do that. Wait, watch this. So now I can get my thing over there on the right and still have this up. Good. So which of the scatterplots show no association? We said they all show some sort of association, like moderate to very strong. So none of the scatterplots show no association. Oh, no worries. They all show some association. Which scatterplot shows a negative association? 2 shows a negative. Remember, we're going to use our help guide on the right. Don't look at those. We're going to look at this over here now. Which scatterplot shows a linear? They all show linear. So they're all linear. They all follow a line mostly. Like some are stronger linear, but they all follow a line. Which scatterplot shows a moderate, a weak, or moderate? That's number 1. Shows a weak or moderate. And then which scatterplot shows a very, ignore this. It's really just which scatterplot shows a very strong. And that's going to be 2 and 3 show very strong. If you look over there at my graphics 2 and 3 show very strong associations. And I think that's got it. Woo, scary question. Let's look at another version of it. And remember, the best thing you can do for these is to mark what you see on them. I want to do a version that has a tricky one. There'll be some tricky versions. That one, but I want to do it where I actually fill out the questions. It's not going to show me it. Oh, wait, what? Okay. So this is showing the answers right here, but with the answers still showing, let's see if we would get the answers. So when you look at this top right one, the top right one is neither positive nor negative. So that's the direction. This one is negative. This one is positive. Then now that we did the direction, let's do the strength of them. This one right here, this is where it's going to get tricky, is probably very strong. This one is very strong too, and this one's moderate. The strength is how tight it is around the form. But what do you notice about graphic 1? Even though it's very strong, it's what? Graphic 1 is very strong, but it's what? And here I'll draw a hint for you. Graphic 1 is very strong, but it's what? Graphic 1, it does have an association. It does have an association. It's very strong. It does have an association. It's just that the association's what? It does have an association. Graphic 1 is associated, which means if you know X, you know something about Y. It's just parabolic association. So it's just that graphic 1 has a what? It's still very strong. It still has a very strong association. It's just that graphic 1's form is what? Graphic 1's form, which I've drawn in red right there, is what? Non-linear. Caroline, great answer. It's not linear. These are linear forms right here. So the correlation for this one is probably close to 0. Correlation for this one is probably close to like negative 0.9. Correlation for this one's more moderate, like 0.6 or something like that. Does that make sense how I'm kind of guesstimating the correlation? Like the third one is more moderate. It's moderate strong, but not super strong. But the second one is the strongest and it's the most negative. It's very strong negative. The first one has a very strong association, but it's non-linear, so correlation. Just by the tightness of it. Remember, the closer it is to a 1, do I still have Wikipedia up? Where's Wikipedia correlation? The closer it looks to a 1, the stronger the correlation. So here's a good general guide on what it looks like. So you can see right here, the more it looks like a 1, the closer it'll be to -1 or +1. So the tighter it is around it. But do remember, things can have a form that's non-linear. So the way I'm kind of guessing these right here and saying -0.9 is this looks more like a 1. If you were to draw around this, you would see that it looks more like a 1, and this looks a little bit more like a 0. So the wider it is, like this is purely a 0 when you draw around it, which means it has no linear correlation. If you draw a line, it's going to be flat through it. Does that make more sense right there, Kayla? That the closer it is to like a 1, the more it is stronger the correlation for the linear correlation. The more it looks like a 0, like this one right here looks a little bit more like a 0. Yep. So that's a good way to check it. One of my students pointed that out a while ago. So which of these show no association? None of them do. And the first one does show an association. It's just that the association is nonlinear. Stop doing that, my Pearson. I want this to go over here. The first one shows an association that's just nonlinear. Which Scatterplot shows a negative? It's only graphic 2. Which Scatterplot shows a linear association? 2 and 3. So 2 and 3 show linear. Remember, we've got this marked over here on the right. Which Scatterplot shows a moderate, a weak, or moderately strong? So we said 3 is the moderately strong, so only graphic 3. Which of them show a very strong? Ignore the middle words. Just look. Which Scatterplot shows a very strong association? And it's going to be both 1 and 2. Remember, I did write these as very strong right here, confirming we knew the answer. So we were able to go through this. This is a tricky question. Really good practice, making sure you understand that things can have an association even if they have correlation equal to 0. But you do have instances where things don't have any correlation, like this one right here, where that has no correlation. Which of them show a negative? Graphic 3. Which Scatterplot shows a linear? Graphic 2 and 3 show linear. These are linear. Which Scatterplot shows a weak or moderate? That's graphic 2 is weak or moderate. That is, graphic 1 is no association at all. It's not even weak. It's just no. And then which of them show a very strong? That's graphic 3. We should get it. Great way to end class right there. Let's go. Exam week. Vincent, you got this. Some 20 points, Vincent, right there. Hackerman just solved it. Make sure you practice. Make sure you can solve it. We'll be starting class here in 17 minutes. That means I need to go get ready for class. I'll see you soon if you're in class. But until then, bye for now, everyone. Bye. Bye, Caroline. Thank you so much, Caroline. Thank you, Vincent. Thank you, Kayla. Keep practicing. You got this.